Alright guys, today we're going to be talking about the greatest common factor, but I need you all to get your Unit 5 table of contents set up. So you need to make sure you have the date, the title, the page number. Today's date is February 5th. The title is going to be greatest common factor, and I'm starting off on page number 1. Feel free to pause the video if you need to. Alright, so make sure that when you have your notes, you have the greatest common factor page set up, and you have the date. Make sure you underline your title. So first we're going to define this thing, and we call it the GCF. Our objective for today, let's do that first, is I can determine the GCF of an expression. So this is going to lead us into this thing called factoring, which is basically the opposite of distributing. Our unit is all about quadratics, so eventually we're going to learn how to factor quadratics, but we need to start with the basics. So now let's go and define our GCF. So it is the greatest number or variable that can evenly, which means no remainder, divide into all terms. Okay, this is called the greatest common factor, but sometimes we shorten it to just the GCF. Alright, so we're just going to go through a bunch of different examples. So if I said find the GCF of all problems, our first problem is going to be, what is the GCF of 60 and 24? So in order to do that, I'm going to start by listing out all the factors of 24. So we've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. And once we go to 5, it doesn't divide anymore, so those are all my factors of 24. Now if I do the same thing for 60, I'm going to have a lot more, so I'm going to start with 60 over here. 1 and 60. 2 goes into it 30 times. 3 goes into it 20 times. 4 divides into 60 15 times. 5 divides into it 12 times. And 6 divides into it 10 times. 7, 8, 9, they don't go into it, and then we're back at 10, so we're good. Now the biggest common factor that's in both of these is our number 12. So our GCF is 12. It's the greatest common factor. So now we can do this with variables as well. So if we look at a second example, if we have 8x squared minus 2x, and we want to pull out the GCF, I want a number that can divide into both the coefficients. So 2 can divide into both of these, and that's the biggest number. And see how they both have a variable? I'm going to go with the variable with the lowest exponent, so x. So I need to think of something that when I distribute this back, I end up with 8x squared minus 2x. So 2x times 4x will give us 8x squared. 2x times what will give us negative 2x? That's going to be negative 1. So my GCF is 2x, But this is what it looks like when you factor it out. So we factored out the GCF, meaning we put it in front of the parentheses. So let's look at another example. So we have 3x minus 15. Okay. Well, I know that 3 can divide into both 3 and 15, so that's going to be my greatest common factor. They both need to have a variable in order for me to pull a variable out as a GCF, so I'm left with this. So we want to be able to, when we distribute this, oh, that's the 15. When we distribute this back, we want to be able to get 3x minus 15. So 3 times what gives us 3x? And 3 times what gives us negative 15? That's going to be negative 5. So my GCF in this case is 3. Alright, now, here's a challenge. So say we have 10x squared plus 2x plus 5. And the question is, do you see a GCF in part of this expression?